Hey everybody, welcome back. Today I'm going to go over some of the homework problems in Chapter 8. I looked at a couple of them. I know in class someone mentioned having a problem with a graphing problem, but they didn't remember which one of the graphing problems. So I'm going to go over a couple of the problems that I thought were representative and covered a lot of the material from Chapter 8 that's important, and hopefully that helps as a little review. So remember, with Chapter 8, we're looking at competitive markets, firms in competitive markets, and their short-run and long-run equilibria, the output decision, and the shutdown rule, right? So the decision of how much to produce, producing the profit-maximizing quantity, and the decision of whether to shut down or not to minimize losses. So the first question that I was going to cover is one of the graphing problems, and it's question 311 in Chapter 8 in the textbook. A lot of the questions in the MyLab are also in the book, and sometimes they have a little different phrasing. Some of them are solved, so it's always a great resource. But this is the one that talks about fracking versus traditional oil wells or traditional oil wells. And basically the point is that fracking has a higher shutdown point than the traditional or the conventional oil does. And so it's basically just going through and identifying what the implications of that are on a graph. So we are given a curve. So we have the curves all in one place, and we've got, like I said, it's so in the book the problem says, according to one of the applications, conventional oil wells have a lower shutdown point than those used for fracking. Use figures to compare the supply curves of the two firms with conventional wells, or the supply curves of conventional wells to the supply curves of fracking firms. Show the shutdown points and the relevant cost curves. And so the nice thing is, in the MyLab, they've already got the curves for you. So I'll go ahead and draw those in. And then we'll identify the shutdown points for both conventional and fracking and the supply curves. And hopefully that'll kind of give you a sense of what we're talking about. So we've got, they share the same marginal cost curve. And then we have a average cost curve or an average variable cost curve for conventional oil wells, and then we have one for fracking. We'll call that AVF. And so it's pretty straightforward, hopefully. I think this is probably not the one that people had questions on, but it's still a nice review. So we go through and say, okay, what's the shutdown point for conventional? It's going to be right here, right? That's that shutdown point. That's the point at which conventional firms would shut down. The point at which a fracking firm would shut down is going to be here. And basically what we're saying is these are the points below which a firm would not produce, right? They're not going to produce below price or marginal revenue equal to average variable cost because they'll be taking on losses. So that's that loss minimizing shutdown rule, right? So you identify the shutdown point on the two average variable cost curves. And then the next thing to do is it asks you to identify the short run supply curve for the conventional firm. And that's going to be here. Everywhere along that marginal cost curve, and above that shutdown point. So that's going to be the supply curve for the conventional firm. And then the supply curve for the fracking firm is going to be this short run supply curve here. Again, along that marginal cost curve. This is getting awfully messy, but still above that shutdown point. And the idea here is one of the big ideas from this chapter, that the marginal cost curve is the supply curve, that they don't produce below average variable cost. And so the supply curve in the short run for these firms is going to be that marginal cost curve above those shutdown points. Make sense? Hopefully that's pretty comfortable. That makes a lot of sense and it's pretty familiar. The next problem looked at actually calculating a profit maximizing firm's output level, profits, and profit maximizing price, and then deciding whether they would shut down. And I really like this problem because it's really representative and sort of encapsulates everything that we were trying to talk about in this chapter, all the big ideas. So this problem is chapter 8. It's 3.1 in the textbook. And there's a couple of different versions of it mathematically, but you can go through and sub any figures in, and the way to solve it stays the same. So for this problem, they said that, is that, okay. Sorry, I'm running out of space. So we've got the market is a competitive market and price is equal to $200. We also have the cost function is 1/3 Q cubed plus 4Q plus 750. And then the marginal cost curve is Q squared plus 4. So if we wanted to, we could always derive the marginal cost by taking the first derivative of the cost curve with respect to Q. But I know we don't do a lot of calculus in this class, so I don't want to blow anybody's mind or take it too far, but that's always really easy to do. So that's how we get that marginal cost curve, but it is also given in the problem. And then we have 4 things we want to do. We find the profit maximizing quantity the firm's going to produce. We want to find out what the price this firm is going to be facing is, and we want to calculate what their profit is, and then decide whether they should shut down or not. And really the big part is calculating that profit maximizing quantity. Everything else is really straightforward. To calculate that profit maximizing quantity, what we want to do is remember that a profit maximizing firm is going to produce where marginal revenue is equal to marginal cost. And in perfectly competitive markets, in a competitive market like this one, price is equal to marginal revenue. So all we have to do is set marginal cost equal to price and solve for Q. So we've got price equals marginal cost is going to be $200 is equal to Q squared plus 4. Subtract 4 from both sides and we get 196 equals Q squared. Take the square root of both sides and we get Q equals 14. So far, so good. Pretty straightforward, right? So now we have a profit maximizing quantity of 14 units. The next question says to calculate or find what the profit maximizing price is. That price is given by the marginal revenue curve. So the answer there, the price is just going to be P equals $200. And then to calculate the profit, we just need to solve for revenue minus costs. And so remember, right, profit equals revenue minus cost. And revenue is going to be price times quantity minus costs as a function of quantity. So $200 times 14 units minus this cost function with our profit maximizing quantity of 14 inserted in. So 1/3 of 14 cubed plus 4 times 14 plus 750 is going to give us, I got it all calculated already, $2,800 minus 14 to the third times 1/3 is going to be 914.66 repeating. And 4 times 14 is 56, plus 750. It's going to give us $2,800 minus 1726.7. So profit is equal to $1,079.33. Cool? Straightforward, right? Just solve it, round. Don't make an algebra mistake. Don't make a math mistake, right? So now we have our profits. They are $1,079.33. So the last question for this problem asks, given everything that we have calculated, should this firm shut down? And remember, we don't see what average variable cost is here, but we can tell this firm shouldn't shut down because you should only shut down to minimize losses. This firm is earning positive economic profits, so they are not incurring losses. So should they shut down? No, don't shut down, right? This is just an excuse to use this super blown out red pen that doesn't have any, doesn't do the good job graphing anymore. So that's another problem. That's problem 3.1. Again, I think that's a really nice representative problem. It's the kind of problem that I would like to ask on an exam, something like that, where you can go through all the steps, you know? The last question is a little bit weird. This is another graphing problem. It is problem 4.11, 411 in the chapter 8 in the textbook. And also a My Econ Lab problem. And this problem talks about oil spills, basically says that oil spills increase demand for all this stuff. The word problems are a little wordy, and I understand that. It's a bit tedious. So I'll take a look. But you know, when you wade through them, the information is less annoying. And that's honestly why I like, if you have the book, going to the book and reading the problem and kind of filtering out some of the words. But anyway, so the idea here is that oil spills increase demand for certain services, things like boats, these cleanup services, etc. And so we want to look at how that affects the market in general and individual firms in specific. And so what we're going to do is look at two graphs simultaneously, and we're going to track these effects in the market and the firm. So if we think about it, we have, I'm going to put them side by side. So here we have individual firms, and so I'm going to call this for cleanup boats. So we've got the firm, and then we have the larger market. And we have some initial demand curve and some initial supply curve. And this is not a calculation-based problem. And so really what we're looking at here is sort of the qualitative effect, the direction and the sort of nature of these shifts. So I'm going to give us some equilibrium, quantity, price, and the book is big, or My Econ Lab is big on labeling the equilibria, in case you forget where an equilibrium is. And then over here we have some marginal cost curve for the individual firm. They're going to face that market price of P1. And they're going to have some average cost curve. Now, one thing that the book, or actually it's actually just an average cost curve, that the book points out, or like the My Econ Lab question points out, is it starts the market in long run equilibrium. So we've got another equilibrium point here. Get a skinnier pen. That'll do. Okay. So what happens when these oil spills come in? There's this massive oil spill. What happens to the market for cleanup boats? Well, the first thing that happens is we're going to see an increase in demand for those boats' services, right? So the change in demand is going to be an increase in demand for those services because they need help cleaning up the boat, right? Or they need help cleaning up the spill. So we can graph that effect, shifting that demand curve out. I'm going to call that D2. That gives us a new higher equilibrium point, E2, and a new higher price, P2. That new higher price, and this is the second part, is translated over here to the firm. And I like having these side by side because then you can see that's what sort of is well, they're connected both ways, right? Both the individual firm and the market graphs are connected by price and by quantity, but I think it's nice to see the price translate all the way across. So the first thing you want to do is identify the new equilibrium now that demand has increased. The next thing you want to do is identify the new equilibrium in the individual firm market, and that's going to be here. This firm is now going to be producing a larger quantity and facing this higher equilibrium up here. So now we want to think about what would happen next. So now that we have this higher price, what's happening in the market? If we were in long run equilibrium before, where price was equal to marginal cost was equal to the average cost, there was no incentive for firm entry. Now there is an incentive for firm entry, right? Now firms are earning economic profits. So the next sort of wave of activity that's going to happen in this market is we're going to see the supply curve shift out. Let me get a good pen for that. So we're going to see supply shift out because more firms enter the market. So higher prices lead to higher economic profit, which leads to firm entry. And an increase in the number of firms is going to shift that supply curve out. That's a non-price determinant of supply. So we get a new supply curve. We're going to label it S3. And we get a new equilibrium point. That's going to be over here at E3, which is actually the same price as before. Now we're at a new higher quantity, right? So the increased price resulting from the increased demand drove supply up by attracting more firms to enter the market. We see the price go up, or we see the price go back down to P1 and zero economic profit prevails. So kind of like returning us to our equilibrium, which is what we would expect in the long run anyway. So that all makes sense. The last part of it asks whether the increase in demand was temporary or not and what it looks like if it would be. So we had an increase in demand, which shifted the demand curve out, which led to increased individual firm quantity produced, increased market quantity produced, and increased prices and resulted in economic profit that was greater than zero, which led to firm entry. That firm entry shifted the supply curve out. That shift out of the supply curve led to lower prices and pushed us to a point where now economic profit is equal to zero and we're in that long run equilibrium again. What happens if the shift in demand was temporary? Well, if the shift in demand was temporary, I'm going to get one more color in here. We'll see demand 2 shift back to demand 1, which means this new equilibrium is going to prevail. Prices are going to go down. We're going to see, or the price will go down temporarily. until we see the firms start to exit in response to the lower price. We're going to see the market quantity decrease. We're going to see the individual quantities produced by the firms stay unchanged, and the number of firms decrease. So what happens is we'll move from E3 to E4. Where'd you go? There you go. And that will lower prices below P1. That's going to lead to firms leaving the market and move us back up to supply curve 1. So in the end, in the long run, we'll resettle in our original equilibrium. We're going to see prices unchanged. The market quantity is going to decrease. We're going to see the firm quantity stay unchanged, and we're going to see the number of firms decrease. Make sense? Hopefully. The big thing here is to understand how profits can alter the market until we achieve that long-run equilibrium. So one of the conditions of a competitive market is entry and exit. If we have free entry and exit, that's part of how we see markets stay perfectly competitive, or how we define a competitive market. It's going to allow firm entry and exit to respond when prices are such that we see profits be greater than or less than 0, because our long-run equilibrium is going to be at 0 economic profit. Make sense? Hopefully. Let me know if you have any questions. If there's another problem you want me to go over, let me know. Otherwise, have a great day, and I'll see you next time. Thanks.